Hello everyone. Looks like time is 11 o'clock and a little bit past already. As we are in a kind of time pressure, then I better start from here. Take over Radek's screen. Like to introduce you lightly coming to our ESSVE Academy. Today's it's on serial number 8 this year. We had 7 at spring, and now we're gonna have 4 or 5 of them at the autumn-winter period. I inform you also that this academy presentation is recorded. We will share you the recording area after the academy itself. Today in present, we're gonna have here me supporting Radoslav. He's a technical sales support in Baltic and Eastern Europe area, located in Poland. And then we have also Eero, who we introduce a little bit later. He's our practical demo dominate part of today's academy. So if I will go here forward, then the agenda of the day is so that we try to fit now in 5 minutes quick intro with some poll questions. Then we're gonna have a case study, today's subject. Then time for feedback, polls, how did you like it? And we have also short news about ESSVE innovation on each next academy. So you are very welcome. Who have those microphones up, I kindly ask you to put them on mute, and Radek, you will release the new incoming listeners or participants.
No. Yeah, thank you. Could you check another slide? Yeah, thanks. Okay.
Going forward here.
Hello.
Talking about the company of ESSVE, then we are known as a green box supplier and founded in 1970. We officially are having an office and present in 7 countries here in Scandinavia and Baltic state, Eastern Europe area. We all together have roughly 200 employees, and we belong to Berman and Bering Group. So each day we sell roughly 5 million screws, and in Swedish crowns we have around 5 billion SEK revenue in yearly basis. Jumping forward, what is our primary application areas? Then here we could say that we are foundation and structure. That's today's subject, and focus timber, building envelope, interior finishing, and then outdoor carpenter areas. So this is our core product area. Then we kindly ask you also to double check who haven't checked the eswood.esve.com website. It's also downloadable on internet directly with your phone on that QR mark, so it's free to use. And maybe some words about myself lightly is that I've been in the fastening business 25 plus years. You find my contact person info with email and the phone, and I'm the technical sales support, you and as a sales team. About ESSVE, today we will touch here the actual loaded connection and sample of alternative solutions. We're gonna have also concrete available, so please feel free to look at the concrete area. If you don't find, ask our support. It's also free downloadable, good software. And ask for pull-out service. So we have also in our present countries option to make a pull-out test on site if you are confused about the quality of base materials and the fasteners. And here we are getting slowly 2 more slides to Eero. Eero, you can lightly prepare yourself, but before we coming to jump in you, I will introduce that he's a senior lecturer at University TalTech in Estonia and a structural engineer. In that part, I also like to release poll. Here is our first poll for you. And I will ask that how do you calculate the capacity of connection today? Is it that you do it manually? Do you use a third-party software, example CLT Toolbox or something similar? Or you do the fastener calculation by a supplier software like ESSVE? Or mostly you use just a low table catalog. So feel free to give 1 or 2 answers from your side, and looking forward to your feedbacks here. At the moment, I see that there is on first, third, and fourth option running an equal position level, and 20% is more manually. Let's say 30% is using supplier software, 40% is also using load tables, and there is also some who are using something else. So feel free to finish that poll. In the same time, I will say that we will look into a different connection samples today, compare the parameters, time, principle of how to make a secure screw fastening connections, working through different samples, and Eero helps us to do that. Before I give the table to Eero, I will also release a second questionnaire to you, and here you will see the day's subject in front of you. So the second one, which I will release it, is related with from where do you find the fastener drawing family or the block? And that's interesting for us to know, where do we need also in the future to invest? Is that gonna be drawing family block, you're not using it, or do you use the block from supplier website, or you use some catalog in like Broadleaf or some other options? So that will be interesting to get your feedback here as well. But here I see that many of them using fastener block from supplier website, which is great, but it's also CAD-in plugin, it's also your own. So all feedback is positive, and we're looking forward. But now, thank you, and Eero, floor is yours.
Thank you. Good morning, everyone. And now, can you see the screen, just to be sure?
Yes, I can hear you and see your screen.
Okay. So my name is Eero Tuhkanen. I'm from TalTech, and it's nice to be invited again to the ESSVE Academy. We started this journey in the spring, and in that time we started introducing the second generation of Eurocode 5. which was more like a general introduction to without any specific examples. And now we are planning some simple examples, which I try to comment and try to find the links to the new Eurocode. And I can also give some suggestions for the designer. And our first topic is cross-screw connection and joist hanger connection. You can see them on the screen. Yeah, it's the both connections serve the same. The both connections have the same intention to hold the secondary beam to the main beam. I cannot say that it's a comparison calculation because we cannot really compare them for regarding to load bearing capacity, but we can compare the connections in other terms, which I try to do later. It means design effort, installing, and the other aspects which are relevant here. The first one is made with crossed screw, and the second one is made with joist hanger. The both products I covered today are from ESSVE, and I can show you where to find relevant parameters for the design. First, I go to this cross screw connection. I was taking the geometry of the connection like this. We have a glue-lam. The main beam is glue-lam 100 times 200 millimeters, and the secondary beam is 90 times 160 millimeters. And I particularly choose the glue-lam because I wanted to show some links to the new Eurocode. This geometry of the connection look like this. You see on the picture. The connection I used here was ESSVE ETT 6.5 times 220 millimeter full threaded screw, or yes, it's called full threaded screw. And if you see on the drawings the measurements here, so if you are a designer and you make the drawing for the carpenter, then you have to, of course, show the points where you have to install the screw, so the carpenter knows how to place the screw into the connection. But if you calculate this edge distances and distances between the screws, you have to be aware that it is calculated in the threaded part center. So it's explained very well in the new Eurocode. It means that this distance to the edge is calculated from the center part of the threaded part, but the installation is not in this point, but in this point. So you have to be aware that. So this is the first remark for the designer. So here are the loads. So we are making this presentation for whole Baltics and Nordic, and here I took the permanent load with the safety factor with 1.35. you can choose, of course, in the factors in your country available. For example, in Estonia, we have 1.2, but this example is made with common Eurocode factors. And here you can see permanent load is 1.2, variable load is 3.6. And the load combinations you have to calculate through are first load combination 1, which includes only the self-weight or permanent loads, because K-mode value is lower in that case. And the mostly decisive load case is where we also have variable load included, and here we have to calculate with K-mode 0.8. That's commonly the decisive load case, but again, you have to be aware if you have very high concentration of permanent load, then it may be that the first load case is decisive. For example, if you use on the floor a timber concrete composite, then the concrete will give quite high permanent load, and then it's necessary to check this load case as well. Here, if we know the load, what we have in the connection, then we can calculate the load to the screw cross or cross screw. So the one screw is in tension in this connection, and the second screw is in compression. So we know the load for both screws. You can also calculate opposite way. You can find the load carrying capacity of the screw and try to find how much load you can add to the beam. So you can basically make yourself a table for that. So it's up to you, but the common way to calculate this connection is that we know the load in the connection, and we can already find out how much load one screw has to carry. So here is the formula how it's calculated. Here, the load carrying capacity of the screw, you have to check here the withdrawal resistance. Withdrawal resistance has this formula. And if you know which screw you use, for example, this ESSVE screw, you can find this document for ETT screw, and you can find this pull out strength parameter FAXK. It's given in the document by the producer. Or the other way is to calculate that according to the Eurocode itself. It has a formula for that, but first it's better to look at the screw provider or the value screw provider provides. And then you have to know this L effective value. L effective is the length of the threaded part, and this value also comes from the document, screw document. And here below, it's the formula which takes into account the angle of the screw related to the timber or wood fiber. So when it's 90 degrees, then it's the value is 1. When the angle is bigger, then we have to reduce the withdrawal resistance. But also you have to be aware that some screw producers are giving this withdrawal strength for kind of let's say from 45 degree to 90 degree. So this is the same value for every angle. But in ESSVE case, we have to consider that this value is for 90 degree withdrawal resistance, but we have to consider the angle between screw and the wood fiber. And that's the reason why here the screw in the joist has lower value, because in the joist we have the angle between the screw and the wood fiber 45 degrees. So you can see that here on the picture, the fiber direction is given here, and 45 degrees is the screw related to this fiber. The second thing you have to calculate is tensile capacity of the screw. It's also given in the document, or you can calculate that based on the tensile strength. But as you see, it's much higher than the withdrawal resistance. So we can easily say that tensile capacity is not relevant here. Tensile capacity is relevant if the screw is very long and the withdrawal capacity goes very high. Then we can meet this situation where tensile capacity is decisive. And the third thing here is a compressive resistance. This screw in compression can buckle here in the timber, and we can calculate this buckling factor for the screw. This is I made here in the slides a slight reminder. This is from the spring academy, where this calculation is presented, how to calculate this buckling resistance. And the buckling resistance depends also on the angle between the screw and the wood fiber, and that's because the buckling is decisive in the joist part, because here the angle is smaller. So based on these three numbers, I can say that decisive is compressive resistance, and I can calculate compressive resistance design value, which is the characteristic value divided by safety factor, and I can say that the load carrying capacity of one screw is 5.33 kilonewtons, which is lower than the load in the screw itself. So we can say that this connection meets the requirements and has 33% utilization rate. The other reminder, which is new in the second generation of Eurocode, is that characteristic withdrawal strength can be higher if the screw goes through at least 4 lamellas. And you can increase the load carrying capacity or the withdrawal strength up to 15%. But in our case, it's not applicable because this screw goes through 2 lamellas only, and here we cannot increase the load carrying capacity of that. But in next academic sessions, I have some examples where we can use this new KMAT parameter to consider the strength increase due to the number of lamellas. And the second way to solve this connection is to use a joist hanger. It's the 3-dimensional metal plate, so-called three-dimensional metal plate, which is also introduced in new Eurocode. And I use the same timber cross sections, and the joist hanger is 90 divided by 145, which means that the width of the joist hanger is 90 and the height is 145. And I used ring shank nails 4x40, which is common product in ESSVE catalog. Also a reminder from the Spring Academy, we have the annex, which is informative. And here we have the way we calculate this type of connection. But the hard thing here is that we have to know the real geometry of the hanger or this product. And so we have to go anyway to the product sheet to find out how are the holes placed where the screws are going in, or nails, to calculate this formula. And the producers have usually the tables for that. This part of the formula is replaced by factor KH1. It means that you go to the product sheet or ETA. In our case, it's ESSVE ETA. The number is here. And you can find the table there. And the table says that you can use full nailing or partial nailing for that. And in our case, I used partial nailing, and I took these values to calculate the load carrying capacity of the connection. Partial nailing means that only the holes next to the beam are filled. Full nailing is that the outer holes are also filled with the nails. So that's the difference. If you use full nailing, you can use the other values here. Also, I need the information for the nail itself, and I calculated this ring shank nail from ESSVE catalog. I calculated the load carrying capacity in share and also withdrawal capacity for this formula. For these two values are now used in this formula I just showed. And according to that, you can find out the load carrying capacity of the connection, which is minimum of the two values. I forgot to mention that this formula includes two parts. So the first formula here is calculating these connections here, which take the joist to the hanger, and the second formula considers how this joist hanger connects to the main beam. So the minimum value of these two is considered. And according to my calculations, I found out that the design value for this connection with partial nailing is not fulfilled. It has 6.1 kilonewton, but we had a little bit over 7.02. It means that we can use full nailing, and we can use these parameters to fulfill the requirements. Or if you know how the holes are placed, you can also calculate yourself according to this Eurocode formula. Let's say not full or partial nailing, but you can add some nails to find out the increase of the load carrying capacity of the connection. But for the carpenter or builder, it's very hard to say that yeah, you have to fill these holes with the nails and some of the nails outside. Also, it's easier to say that partial or full. So it's otherwise it's going to complicate it. So the conclusion, we can find load carrying capacity for both connection, and we have to calculate that in that way that the both are carrying the load. But one difference here is the installation time. So if you install 2 screws, so our experience is that if it's well prepared, it takes around 2 minutes, and the joist hanger takes around 6 minutes. This can be relative. Some people are lazier, or it's not too well prepared. But this is approximate difference of the installing time. Sometimes the builders say that it's easier to install the joist hangers and then put the secondary beam into it, but you can also do that in this case. So you can screw or nail here downstairs the let's say one small timber lattice to hold all the secondary beams in place, and then you can easily install the screws. So it's up to you. Design effort. Design effort is longer, or it takes more effort to calculate, of course, the joist hanger, because the steps you need in to calculate full threaded screw are not so. There are fewer steps, and if you calculate this joist hanger, you really have to go to the producer catalog to find the right line and the right factors for that, to understand where to put them. And for me, maybe I have not too much experience with such calculation. For me, it took much more effort. But if you create, let's say, Excel sheet for that, it's easier to create Excel sheet for the screw connection, because for Excel sheet, you don't have to all the data the producer provides as an Excel, and you have to do some of the work manually. So you can build up your Excel sheet, but you have to find the right factors from the table. So that's all from my side. Next time, I think we have the topic how to strengthen the beam if you have a renovated building and you need to add load, how to make the beam stronger, and I show some options for that. So thank you.
Thank you too, Eero. And as we are exceed the time, I kindly ask you, if you have some open questions, put it in the chat field. You can even, after our academy, add some questions there. We normally pick them up and coming back to you. What I like to share here more is that, as I promised, I will show you what's coming next. So the next one is the 5th of November. Eero already explained what we're going to have it. Then we're going to have a 3rd of December. We bring in the ESSVE sample in lateral connection versus metal angle brackets. And then January on, we will introduce already November Academy. About ESSVE innovation, I have small tips on similar connection where we have a main beam or secondary beam, but they are on metal. ESSVE have a stud bracket. Stud bracket is possible to fix with nails or screws in metal area. It's a fast installation, more ergonomic and secure connection. Here's some diagram of the loads. The blue one is a stud bracket loads, which shows that it's the highest value on deformation point of view. And here you find also the innovation.essve.com website. If that's going to be an interesting area for you, we can having different innovation academies also in winter, spring next year. But the stud bracket itself helps to stiffen all the opening areas, leaves you less cracks on facades in internal and external side. So just for your info, that such a exclusive product from ESSVE side is available. And the day is used in Nordic, in Scandinavian market, in Sweden and Norway. The supplier of the product is Knauf or Norgips. So that is a little bit about innovation side. Next time we will pick up another product here from the list. And here is our technical experts who support you on the Baltic State side. As I mentioned, Radoslav in Poland. We have also here today Victor. If you have open questions, you will find his contacts here and me. And as we are in the end of our today's academy, before you leave, I will also release the final poll with your feedback. How was it? How did you feel it? How you evaluate it? So it's coming now on the screen, and looking forward to your feedback on chat side as well. So from my side, all, thank you very much, Eero. Thank you, Radoslav, and Victor, you support being in online today, as we were on heavy time pressure, so we maybe didn't have a much time for open chat questions. At the moment, I don't see yet any chat area questions, but thanks a lot and have a good day.
Thank you.
Thank you.